Hello everyone, and welcome to Earth Archives. Today we're going to dive into a topic that has always intrigued and fascinated humanity: the origin, expansion, and future of the universe. This is not just an academic question. It also touches on how each of us views our own existence. From the Big Bang to our current understanding of the cosmos and its future destiny, these questions have puzzled scientists and philosophers alike, even every ordinary person, throughout history. Today, we will explore these topics in depth, helping you gain a more comprehensive understanding of the universe, and perhaps even inspire new ways of thinking about time and space. Are you ready to embark on this cosmic journey with us? Let's get started. The birth of the universe, the beginning of the Big Bang. The birth of the universe has always been the ultimate question for human exploration. Throughout history, many philosophers, mystics, and scientists have proposed various hypotheses and theories about it. However, it wasn't until 1929 that a significant breakthrough occurred in the scientific community. At that time, American astronomer Edwin Hubble made a groundbreaking discovery that shook the field of astrophysics. By observing the light waves from distant galaxies, he found that these galaxies were moving away from us at varying speeds and distances. More importantly, the speed at which these galaxies were receding from us was proportional to their distance, a phenomenon that later became known as Hubble's law. This discovery revealed an unprecedented fact: the universe was expanding. What was once thought to be a static universe was, in fact, constantly changing and expanding. So, what does this discovery mean? The shock of Hubble's law was not just the realization that the universe is dynamic, but it also suggested that the history of the universe did not begin in an infinitely distant past, but rather had a specific starting point. If we were to reverse time and go back to the early universe, all the galaxies would appear to converge at a single point. This point is referred to by scientists as the singularity. It is not only the source of all matter and energy, but also the starting point of the universe, which forms the foundation of the Big Bang Theory. The Big Bang Theory proposes that approximately 13.8 billion years ago, the universe originated from an extremely dense and high-temperature singularity. Following a violent explosion, the universe began to expand and has continued to do so ever since. This theory explains why the galaxies we observe today are all moving away from us, providing clear evidence of the universe's expansion. From that moment on, the evolution of the universe entered a new phase, with the birth of galaxies, the formation of stars, and the interstellar structures we see today, all stemming from this explosion that began at the singularity. Moreover, Hubble's discovery also changed our understanding of time and space. In the past, our concepts of time and space were confined to fixed, unchanging frameworks. But now, with the discovery of the universe's expansion, we must reconsider these concepts. In fact, the expansion of the universe causes space itself to constantly change, which helps us understand that the universe is not static. It is expanding as time progresses, opening up a new era in astronomy and physics. The Big Bang, the singularity explosion 13.8 billion years ago. According to the primary theory of modern cosmology, the birth of the universe about 13.8 billion years ago did not originate from an ordinary star, but from an extremely high temperature and high density point known as a singularity. This singularity was denser than any matter we observe today, so much so that even light could not escape from it. It was an incredibly mysterious and extreme state until, at some point, it suddenly exploded in a violent burst, which is what we refer to as the Big Bang. The Big Bang Theory states that within this singularity, all the matter and energy of the universe were concentrated in an extremely small region, with temperature and pressure reaching unimaginable levels. It was the explosion of this point that led to the beginning of the universe. As the explosion occurred, the universe began to expand at an incredibly high speed, gradually transitioning from an infinitely small, highly dense state to the vast cosmos we see today. In this explosion, space itself began to expand, and this process is still ongoing. Over time, the temperature of the universe gradually decreased, allowing matter to begin to condense, forming the initial basic particles, which eventually led to the creation of galaxies, stars, planets, and other structures. The Big Bang not only changed the structure of matter, but also altered the very nature of space and time, laying the foundation for the universe we know today. It is important to note that this process was not a simple one-time explosion, but rather a continuous expansion. The expansion of the universe did not stop after the initial explosion. In fact, this expansion process is still continuing, which is why we can observe that most galaxies are moving away from us at an accelerating rate today. Hubble's law reveals this phenomenon, allowing us to confirm the fact of the universe's expansion and further speculate about the origins of the Big Bang. The early universe after the Big Bang, from disorder to order. At the moment the Big Bang occurred, the universe began to expand at an unimaginable speed, even surpassing the speed of light. In just 10 to the power of negative 32 seconds, the volume of the universe grew to an incomprehensible size. This expansion was not a traditional explosion, but rather a rapid expansion of space itself, causing the universe to undergo drastic changes in an incredibly short period of time. As the universe expanded, its temperature dropped sharply, transitioning from an initial extremely high temperature to a more manageable level. In the first few seconds after the Big Bang, the temperature of the universe reached around 10 billion degrees Celsius. Such extreme temperatures made it impossible for matter to exist in a stable form. Even the most basic particles, such as protons, neutrons, and electrons, could only exist in highly unstable states under such conditions. As the expansion continued, the temperature of the universe gradually decreased, allowing these basic particles to stabilize and, within minutes, form the first light elements, hydrogen and helium. This process, known as nucleosynthesis, was a key event in the early universe, paving the way for the formation of galaxies and stars in the future. However, despite the formation of these basic elements, the universe was still too hot to form stable atoms like those we know today. During this period, photons, light particles, could not travel freely through the universe because they constantly interacted with high-energy particles, preventing stable light propagation. In this environment, the universe was filled with countless photons and particles colliding with each other, creating a blurry, chaotic state across the cosmos. It wasn't until about 380,000 years later that the temperature of the universe dropped further, reaching around 3,000 degrees Celsius. At this point, the particles began to cool and combine into stable atoms in a process known as recombination. With the formation of atoms, photons were no longer constantly absorbed and could travel freely through the universe. This led to the release of what we now observe as cosmic microwave background radiation, CMB. This microwave radiation is direct evidence of the Big Bang, and scientists can trace back to the early moments of the universe's birth by observing these microwaves, further confirming the Big Bang theory. The birth of galaxies and stars, the growth of the universe. In the millions of years following the Big Bang, the universe gradually cooled, and gas clouds began to contract under the influence of gravity, eventually forming the first generation of stars. These stars were not ordinary like our Sun. Their masses were typically 30 to 300 times that of the Sun, which made their brightness far greater, shining millions of times brighter than our Sun. These stars became dazzling beacons in the universe. Made primarily of hydrogen and helium, their birth marked a major turning point for the universe. These stars not only provided light and heat, but also created the conditions necessary for the formation of later elements. The lifespan of these stars was relatively short, as their large masses caused them to burn through their fuel at an extraordinarily fast rate. Once they exhausted their fuel, these stars underwent a dramatic explosion known as a supernova. During this process, the outer layers of the star were ejected into space, containing elements heavier than hydrogen and helium, such as iron, aluminum, and oxygen. The distribution of these elements not only altered the composition of the universe, but also provided the essential raw materials for the formation of later galaxies, planets, and even life. Supernovae were not only the way stars met their end, but also the source of many important elements in the universe. These heavy elements spread throughout the universe, where they interacted with surrounding gas clouds and, under the influence of gravity, continued to condense. Eventually, they formed new stars, planets, and other celestial bodies. This process paved the way for planet formation and created the necessary conditions for the emergence of life. In fact, all the elements on Earth that we know today, whether silicon and oxygen that make up rocks or carbon and nitrogen that form life, originated from the heavy elements scattered by these first-generation stars after their supernova explosions. Supernovae were not only the way stars met their end, but also the source of many important elements in the universe. These heavy elements spread throughout the universe, where they interacted with surrounding gas clouds and, under the influence of gravity, continued to condense. Eventually, they formed new stars, planets, and other celestial bodies. This process paved the way for planet formation and created the necessary conditions for the emergence of life. In fact, all the elements on Earth that we know today, whether silicon and oxygen that make up rocks or carbon and nitrogen that form life, originated from the heavy elements scattered by these first-generation stars after their supernova explosions. The current universe, the mystery of dark matter and dark energy. As time has passed, the universe we see today has become an expansive space filled with stars, galaxies, stars, and planets, all seemingly clear and well understood. However, despite our many deep insights into the universe, there are still many mysteries that remain unsolved. As we delve deeper into the composition of the universe, scientists have found that the true nature of the cosmos is far more complex than we had imagined. Among these mysteries, dark matter and dark energy are two enigmatic phenomena that to this day cannot be directly observed, but account for approximately 95% of the mass and energy in the universe. This means that the ordinary matter we can see is only a tiny fraction of what exists in the cosmos. In 1933, scientists first discovered the presence of dark matter by observing the movement of galaxies. They noticed that the speed at which galaxies were moving far exceeded the gravitational influence that should have been acting on them. This phenomenon could not be explained by ordinary matter, suggesting that there was some unseen substance exerting a massive influence on the motion of galaxies. These mysterious substances were then referred to as dark matter. Although we cannot directly observe or detect dark matter, scientists have inferred its existence through its gravitational effects on surrounding matter. The true nature of dark matter remains unknown, but we do know that it seems to play a crucial role in the structure and motion of galaxies. Without dark matter, the gravity required to maintain the current structure of galaxies would be insufficient, and galaxies could potentially break apart or behave in a completely different manner. At the same time, dark energy, another mysterious force, is also influencing the fate of the universe. In 1998, astronomers discovered that not only is the universe expanding, but its expansion is accelerating. This finding completely shattered the expectations of the time. According to previous understanding, the expansion of the universe should have been slowing down over time, but in reality, the expansion rate continued to increase, a phenomenon that still baffles scientists today. After years of research, scientists believe that this accelerated expansion is caused by dark energy. Dark energy makes up about 70% of the universe's total energy, and its existence is critical to understanding the future development of the universe. It remains one of the hottest topics in current cosmological research. The origin of time and space, the Big Bang and the birth of time. When we discuss the origin of the universe, we always encounter a perplexing and profound question. Where did time come from? Did time exist before the Big Bang? This is a question that countless philosophers, scientists, and thinkers have pondered throughout humanity's exploration of the cosmos. This question still lacks a definitive answer, but the famous physicist Stephen Hawking offered some thought-provoking ideas in his research. Hawking once proposed that, before the Big Bang, neither time nor space existed. In other words, time and the universe itself were born together. This means that before the Big Bang, there was no concept of time as we understand it. Such a viewpoint challenges our fundamental understanding of time and defies our intuitive sense of the passage of time. In our everyday lives, time seems to be everywhere. It accompanies us every day, guiding our lives and actions. However, Hawking's theory tells us that time and space did not always exist, but rather were the result of the birth of the universe. The Big Bang marked the beginning of time, and this has become a cornerstone of modern cosmology. From that moment on, the universe began to expand, and time unfolded along with it. This viewpoint helps explain why we cannot comprehend anything before the Big Bang, because the very concept of before itself becomes meaningless. Time is not an infinitely extending concept, but is closely tied to the birth of the universe. Time truly began to flow only when the universe began to expand. The time we know is always closely related to our perception and the functioning of the universe. For example, the Earth's rotation and revolution create our days, nights, and seasons, natural rhythms that give us our concept of time. However, for other celestial bodies in the universe, the flow of time might differ from our experiences. The movement of galaxies, stars, black holes, and other cosmic bodies, whether expanding, contracting, or dying, are all part of the flow of cosmic time. However, Hawking's theory also reminds us that time is not so simple. As scientific technology continues to advance, scientists have gradually revealed the fascinating connection between time and space. Near black holes, the flow of time changes, a phenomenon known as time dilation, which is closely related to Einstein's theory of relativity. This tells us that time is not absolute. It is affected by factors such as matter, energy, and gravity. This profound understanding of time prompts us to rethink the structure, origin, and future fate of the universe. The future of the universe: expansion, end, and cycles. What will happen to the universe, this vast and boundless space? While we live within this grand and profound cosmos, we are filled with countless speculations and curiosity about its ultimate fate. From the initial Big Bang to the current infinite expansion, scientists have long been seeking answers. Will the universe continue to expand forever, or will it one day stop, or even reverse back to the initial singularity? Currently, based on various observations and mathematical models, the scientific community has proposed several theories about the end of the universe, attempting to explain its destiny. First, the Big Rip is one of the more startling theories. If the effect of dark energy continues to strengthen, the universe's expansion will accelerate until it reaches a limit, making this expansion uncontrollable, ultimately tearing apart all matter in the universe, including stars, planets, and even atoms. In this scenario, the universe would become increasingly unstable, and eventually, all matter would be broken down into its most fundamental particles. While this theory sounds terrifying, it undoubtedly represents one of the extreme possible outcomes for the universe. Next, there's the Big Freeze theory. This theory assumes that the universe will continue to expand, and the effect of dark energy will remain stable. Over time, stars will exhaust their fuel and be unable to continue nuclear fusion reactions, causing all stars to extinguish. At this point, the temperature of the universe will gradually decrease until it eventually falls into a state of cold, desolate emptiness. Such a universe would become extremely barren, devoid of light, and without life, leaving only a cold, indifferent void. However, not all theories predict such a lonely end for the universe. The Big Crunch offers a more pessimistic view. According to this theory, the expansion of the universe will eventually slow down as the gravitational pull of the universe's matter and dark matter increases, eventually overcoming the expansion forces. As time progresses, the universe's expansion will decelerate, reverse, and all matter will once again collapse together. Eventually, everything will return to an extreme singularity, resembling the universe's origin, forming a reverse Big Bang. This theory depicts a cyclical end for the universe. Finally, there is the cyclic universe theory, which suggests that the universe may be part of an ongoing cycle of expansion and contraction, with each Big Bang leading to a new phase. In other words, the universe won't have just one life cycle, but will go through countless cycles of expansion and collapse, each bringing about a new beginning. Such a universe resembles an eternal, unceasing living entity, endlessly recurring. The end of time, meaningless time. Even though the end of the universe may seem distant, when we attempt to understand the arrival of that day, many profound questions come to mind. If the matter in the universe eventually disappears completely, leaving only faint background radiation, then what is the meaning of the passage of time? In such a scenario, the end of the universe may not only be the disappearance of matter, but also the end of time itself. As the famous physicist Stephen Hawking once proposed in his black hole evaporation theory, the process of the universe's demise may be accompanied by the dissipation of time. According to Hawking's theory, black holes, after a long period, will slowly evaporate and disappear due to Hawking radiation. This means that even powerful celestial bodies, like black holes, cannot escape the fate of an eventual end. Hawking pointed out that during this process, matter will gradually dissipate until everything in the universe becomes undetectable. In the end, only faint radiation remains, as if the passage of time has stopped at that moment. The arrival of that moment may also symbolize the end of time itself, where the flow of time seems to have no basis and no longer holds any meaning. If the end of the universe is indeed the disappearance of time, then how do we understand this process? Our current lives depend on the orderly flow of time, where the past, present, and future form a clear structure in our cognition. Time gives rhythm to our lives, allowing us to experience, learn, and grow within this finite existence. However, if the flow of time no longer exists, does that mean the very meaning of the universe will vanish as well? If we can no longer measure time, will everything lose its significance? Such contemplation feels both profound and somewhat terrifying. The end of the universe is not merely the disappearance of matter. It may bring a fundamental restructuring of our understanding of time and life. Even so, this ending might also be the natural course of the universe, an irreversible process. Perhaps meaningless time is the true symbol of the universe's end, as it suggests the conclusion of everything, from matter to time, from life to existence, all descending into disorderly chaos. Our universe, our choices. No matter how the universe ultimately ends, for the tiny lives that inhabit it, the most important thing is undoubtedly how to live a meaningful life within this limited time. Perhaps the vastness and infinity of the universe make us feel insignificant, but each person is the center of their own universe, with their own stage in life. In this vast world, what we can possess is the power to choose our own way of life, and how to fill that life with meaning is the core issue we can all control. Finding our own place in this universe is a question worth pondering for each of us. Everyone has different talents, backgrounds, and experiences, and these elements together shape our uniqueness. Perhaps we don't need to find a fixed position to prove our value. What truly matters is how to find space for self-realization in our daily lives and feel inner peace and fulfillment in the process. Whether it's following our passions, helping others, or becoming a light in someone else's life, these are all parts of our place in the universe. I hope today's content has given you a new understanding of the universe and sparked deep reflection on your own life. If you enjoyed this topic, don't forget to subscribe, like, and share this video, so more people can join in exploring this vast, boundless universe.